Intensity of sound or light. What factors determine how intense the sound or light is going to be for an observer? One of the factors is the distance the observer is away from the source of sound or light. So we can see that when we move this observer closer to the source, the sound is going to be way more intense. When we move them farther away, it will become less intense because the sound energy will have spread into a much bigger region. So our factors that determine intensity are going to be distance from the source and also how powerful our source is. If we make a weaker source, the intensity is going to be much lower. Okay, so if we look at these spheres that were created by either a source of sound or light, we can see that sphere C is the largest of the spheres. It's the one that was created first, and the energy is going to be most dissipated. So if we want to know the intensity of the sound at region C, we use the formula that says intensity equals power of the source divided by 4 pi r squared, where 4 pi r squared is the area of the sphere at the location that we're looking. So you use the distance you are from the source to where you are, find the area of a sphere that would encompass that region, and use that as the denominator in your equation. Okay, so to see how this works out, let's look at this problem. We have a sound wave started by a source that provides a power of 0.15 watts. I want to know how intense the sound is going to be 3 meters from the source, and then how much energy it's going to give to your eardrum in a minute if your eardrum is circular with a radius of 5 millimeters. Okay, so to start it out, we use the intensity formula. We plug in 0.15 as the power, 3 as the radius, and we find an intensity of 0.00133 watts per meter squared. We then need to find the area of the eardrum. So the eardrum is a circle, so we use area equals pi r squared. The radius is 5 millimeters, so we use 0.005 meters, and we get an area of 7.85 e-5 meters squared. Okay, if you then look at the intensity and the area, when we multiply these together, the meter squared on the bottom will cancel with the meter squared up top, and we will get a power at the eardrum of 1.04 e-7 watts. We then use our power equation. Power equals work over time. We're doing it for 1 minute, so we plug our power in. We plug in 60 seconds, and you get a work of 6.3 microjoules, e-6. Okay, I'd like you to try one on your own now. So imagine a situation where a calculator has a solar panel that is 5 centimeters by 1 centimeter. The calculator is held 50 centimeters away from a 60-watt bulb, and I want to know how much energy the solar panel on the calculator will absorb in 1 hour. Assume it's 100% efficient. Okay, take a minute to do this, pause this, and then come back and see if you got the right answers. Okay, you should get an intensity of about 19 watts per meter squared. You should get an area of about 5.5 e-4 meters squared. That gives you a power of 0.0106 watts, and that gives you an energy in an hour of 37.8 joules.